Hello and welcome to Quadratics 1.3, the parent graph. Okay, so in today's lesson I'm going to teach you guys about the graph of a quadratic function, which is also known as a parabola. Okay, so if your teachers ever talked about parabolas in other classes like Algebra 1, parabola and quadratic function graph are pretty much the same exact thing. Okay, so basically how you get the shape of this graph is, in the easiest sense of showing you guys how this is made, let's just make a table. Yeah, when you make a table, you just pick random x values that when you plug in for x, in this case you're going to square it, and you get all these numbers in red. Yeah, and when you pick all these random negative values, you plug it in for x, you square it, you get all of these y values or f of x values in red. Okay, and same goes for fractions. You pick positive fractions, you pick negative fractions, you plug it in for x, you square it, you get 1/4, 1/9, 1/16. Okay, and if you were to plot all these dots, you would pretty much get the shape of this graph on the right side. Okay, so this is a video, so I'm not gonna give you time to write down the letters or the numbers rather, because yeah, just hit pause. Okay, let's just move on. Okay, so the next question is going to say, let's write the domain and range for the function f of x equals x squared. Okay, so hopefully you remember that domain is basically dealing with inputs, and inputs deal with the letter x. Okay, so what numbers did we plug in so that we could get the f of x values or the y values? Yeah, and that'll be the x values that we plugged in, like 1, 2, 3, 4, or 1/2, 1/3, 1/4, right? So those are all my x values. Okay, so let's go back to the graph, and let's take a look at these arrows, the arrows that are facing up. Okay, so these arrows are facing up, signifying that the graph goes up forever. Okay, but what kids sometimes fail to realize is, yeah, it's going up, but it's not going straight up. Okay, as it goes up, it's also going to be going left and right. Okay, so this graph is not just sticking at 1x and just going straight up from that 1x value. It's getting wider also. Okay, and since domain deals with the x values that we need to make this graph appear on our paper, okay, and since this graph is going to constantly get wider as it grows taller, okay, we got to remember, yeah, that this graph is going to get wider as well as go up and down, or not up and down, but up rather. Okay, it's going to get wider, and because it's going to go and get wider forever, what kind of x values do we need to make this graph appear in our paper? And you're going to hopefully say, well, I need all of them. Yeah, so how can I write a mathematical statement that says I need all the x values that are in existence? Yeah, and this is how you do it. Well, maybe not. Yeah, this is how you do it. Okay, so you just go the braces. Yeah, you put the braces symbol. Like, it's not parentheses, but it's braces, right? That's what they call it. And you go x colon all row numbers. Okay, and don't forget to write the x colon, because that's pretty much going to tell you which letter we're defining, as far as telling you which numbers we're allowed to use for that letter. So for all row numbers, we're defining the x, what x can be. Okay. So range, I hope you guys realize that range deals with the up and down direction of the graph. And since this graph is pretty much only going up, yeah, and it's not going down, yeah, it's gonna not say the phrase all row numbers, because if you look at the graph, does this graph exist on the bottom, like the negative part of this x and y axis? Does it appear ever on the bottom? No, this graph is only appearing above 0. Yeah, it's only on the top of the x-axis. It's only appearing above 0. So when I write the statement for range, we're going to write f of x, right, braces f of x, colon f of x is greater than or equal to 0. Okay, so the first f of x tells us what we're defining. We're going to tell you what f of x can be. And then the second f of x tells you what the f of x values has to be, that the f of x values have to be greater than or equal to 0. Okay, so reading this the first time, seeing it the first time looks kind of confusing. Okay, so here's how you can translate this into an English statement. Yeah, this is how I do it. This is how I teach my kids every year. So when I see the letters f of x, f parentheses x, which you say f of x when you read it out loud, I see this and I think of the graph, because f of x is a graph. So I say to myself, the graph, yeah, the height of the graph is greater than 0 or it's equal to 0. Yeah, or let's see, how did I write it? I think I wrote it in a little bit different way when I actually made this slide. So I wrote the graph is on or above 0. Yeah, maybe I should write the height of the graph. Yeah, so I guess maybe since this is range, we can talk about something about the height, right? So the height of the graph, yeah, the values that represent the height are going to be either on 0 or greater than 0. Okay, And you get this 0 value because if you look at the previous slide, this graph is at what height? What is the lowest height that this graph ever reaches? And the lowest height it ever reaches is a y value of 0. Okay, so the lowest that it reaches is going to be part of my range answer. Okay, so make sure you guys know domain and range really well because it's going to be sticking around for the whole year. Okay. All right, let's see what's next. Question 3. So what are the coordinates of the vertex of the graph? So if you guys remember from your Algebra 1 days, I'm pretty sure they kind of taught you guys about parabolas, and they taught you that the vertex is going to be either the highest point on the parabola or the lowest point on the parabola. And in this particular parabola that we have here, this is going to be the vertex right here. So let me get the pen ready, and the vertex is right there. Wait, why isn't it writing? Oh, maybe I didn't switch to pen. Okay, so the vertex is, like I said, either the highest or the lowest coordinate in the entire graph. So my vertex is right there. Okay, and it's going to be the lowest point of the entire graph. Yeah, so that's my vertex right there at that dot right there. Okay, and he has a set of coordinates called, and hopefully you guys remember how to do coordinates, 0, 0. Yeah, and that should be correct. So let's unhide the answer, and it should say 0, 0. Yes, it does. Okay, so then it's talking about evaluating the y-coordinate of the vertex. So, like I told you earlier, when you look for the vertex, it's either going to be the highest point of the parabola or the lowest point. Okay, because parabolas can do two things. So in the top statement, if the parabola opens up, that means that we're dealing with a parabola that looks just like the one a couple slides earlier, where it looks like a U. Okay, so if your parabola looks to be like the shape of a U, then we're going to say the parabola opens up because the arrows are pointing up basically. And when we evaluate the y-coordinate of the vertex, we call that a minimum value. Okay, and I call that a minimum value, and the reason I explain it to my kids is I call this a minimum is basically because it's at the bottom of the valley. Okay, so if you think of the parabola as a shape, it looks like a valley, and the vertex is at the bottom, or the minimum. Yeah, the lowest height, lowest part of the valley. So I call that minimum. So minimum, lowest point. Yeah, they all kind of mean the same thing. Okay. And in your second statement, it says the parabola opens down. So what does a downward opening parabola look like? So it looks basically like this, where you got your parabola, and the arrows are facing down now. So your vertex is all the way up on top. So I call this, or I don't call it that because that's what it's actually called, but the way I describe this is it's like a hill. And when you're at the top of the hill, you're at the highest point. Yeah, and when you think of highest point, you hopefully relate that to word maximum. So highest point, maximum, bottom of the valley, minimum. Yeah, so from when I'm at the top of the hill, this is the maximum height, and I'm at the top of the hill. There's nothing higher than me, so that's my maximum. Okay, so you're gonna qualify or label that y-coordinate of the vertex as a maximum value. Okay, so in this particular problem, it says, does the function f of x equals x squared have a maximum or minimum value? And I think we know it's going to be a minimum. And it says state the value. So what is that going to look like when I have to state the value? Well, pretty much I'm telling you, or I'm categorizing the value of the y of the vertex, which in this case is 0, as a minimum. So how do I write this out? I go minimum value, right? Because that's a parabola that's at the bottom of the hill at y equals 0. Yeah, so I'm saying at y equals 0, it's the lowest point on the entire graph. Okay, so I hope this lesson kind of made sense. Yeah, you're gonna see this labeling of maximum and minimum happen on a lot of problems after this. So don't worry, it's not the last time you're gonna see it. So we're gonna get lots more tries to master this concept. So don't worry about this first time. Okay, so I'll see you in class. Bye bye.